Good morning, everyone. Dave Arscott, incoming president. At noon, I guess, I'll be president of this society. Thank you all for getting up early and joining us for plenary. I have the pleasure to announce another one of our society awards, the Hynes Award for New Investigators. The Hynes Award is awarded to a freshwater scientist who was senior author of an outstanding primary publication that appeared in the final print or online format in the last 3 years. The recipient must have received their final postgraduate degree within the last 5 years. This year's recipient of the Hynes Award for New Investigators is Dr. Ayan Fleischmann. Yeah. A little background before Ayan joins us on stage and gives us a short summary of his work. Dr. Fleischmann is an interdisciplinary hydrologist working with tropical hydrology and sustainable development of wetlands, especially in the Amazon region. He holds an environmental engineering degree from the Federal University of Rio Grande do Sul in Brazil, and a PhD in water resources and environmental sanitation from sort of dual institutions, the Rio Grande do Sul and the University of Toulouse with Paul Saboteur. He is currently a full researcher and leader of the research group on geosciences and environmental dynamics in the Amazon at the Mamaro, sorry, I'm killing it, Institute for Sustainable Development in the Central Amazon. His research focuses on understanding the hydrology and climate of tropical wetlands and the impacts of past and current future climate and environmental changes on social ecological systems within riverscapes. He also coordinates a research network in Amazon for science outreach related to Amazon communities. Dr. Fleischmann is, of course, our Hynes awardee primarily or selected for his publication titled Increased Floodplain Inundation in the Amazon Since 1980, published in Environmental Research Letters in 2023. The paper presents a broad assessment of recent inundation trends and impacts in the Amazon basin. I hope you'll check it out and read it. It's a wonderful paper. We look forward to hearing about your insightful research. So once again, please join me in welcoming Dr. Fleischmann to the stage.
To change the slides? To change the slides?
Let's do a photo first.
Oh, yeah.
Oh, there we go.
1, 2, 3. 1 more. 1, 2, 3.
And maybe take a look at Andy once? No? You got it? All right. Congratulations.
Yeah.
We'll put it on the back table.
Yeah, thank you very much.
Yeah. Green is forward, red is backwards.
Yes, thank you. Thank you, Dave. Thank you, SFS, for the award. Thank you, Steve Hamilton, for the nomination for this, all this time of collaborations and friendship. So, morning, everyone. Initially, I was supposed to talk about increased floods, because this is what the paper is about. But actually, the Amazon has been changing a lot recently. So this is why I decided to bring a much broader picture of what's going on in the region, and more especially what we can do to help it. So if you can load the presentation, please. Yeah, so Amazon waters are changing. Can go on. So this is the Amazon. Most of you certainly know it, the largest basin on Earth, around 20% of river waters that reach the oceans, more especially the Atlantic Ocean. A large fraction of global biodiversity, a major role in global carbon, climate, water cycles, and a lot of people that for millennia have adapted to the system, to this very unique system with a major flood pulse that occurs every year. The water comes in, goes down every year, and now these social ecological systems have adapted for a long time to cope with the challenges that this dynamics brings. So just to give an understanding of where I am located today. So that's the map of the basin. Right in the heart of it is where the Instituto de Desenvolvimento Sustentável Mamirauá. Mamirauá comes from an indigenous language in Brazil and means the baby of a manatee. So a small manatee animal is Mamirauá. So Mamirauá is a research institute associated with the Brazilian Ministry of Science and Technology, and I'm today a full researcher there. There's already 3 years I've been there. And as I said, these social ecological systems have adapted to a very unique and a fantastic system. So for instance, this is a community very close to the city of Tefé, where I live, and there water levels can vary up to 11 meters every year, from flood to the dry season. And not only it changes, has this very high water level amplitude, but it also has a very wide cover along the floodplains. So close to Tefé, we can have up to 90 kilometers wide of flooding. That's a lot. And these communities, these Ribeirinho people, these animals, such as the jaguar, have adapted, as I said, but are they really adapted to what's going on today and related to what has gone in the last decades? So these are major topics that we need to understand. For instance, that jaguar you see there, that black jaguar, has created a very unique adaptation that has only been found in this place of the Amazon. This animal lives at the top of the canopy for 3 to 4 months every year. So this is a very, very fantastic adaptation. You can see there at the top of the left picture there, this is a tree, a flooded tree. At the top of it, 15 meters above, there is the jaguar. But can it cope? If it can cope with 3 months of flooding, can it cope if this flooding duration becomes 4 months or 5 months? So this is the type of things that we really need to understand regarding Amazon changes. And all these challenges require new tools, new information, new ways to understand this very unique system. One such a way is remote sensing. The Amazon has been a true laboratory of space research development in the last decades. We've published this paper recently where it tried to bring a whole summary of what remote sensing has brought to the Amazon and what Amazon has brought to remote sensing as a discipline. So as a hydrologist, I was initially taught, and I learned a lot how to estimate river discharge. This is a fundamental hydrological variable. But there are other variables that are fundamental as well, to understand changes in these very adapted floodplain ecosystems and floodplain people. So remote sensing can promote such a change to move beyond understanding only river discharges and think about a more holistic understanding of water cycle and its variables. For instance, water levels. There are just a few operating water level gauges in the Amazon today. But remote sensing is providing a whole revolution on that. So each dot here is what we call a virtual station. So it's the cross of a satellite track with a river. Today we have up to, I think, now should be around 15,000 virtual stations across Amazonia. Each of these stations has a time series of water level and can provide a lot of information that we didn't have in the past. And especially now with the launch of SWOT mission, which is a true revolution for hydrology, for global hydrology. This is a joint NASA and CNES, the French Space Research Center. That is the first hydrology-oriented mission to track surface waters globally. So this mission will be able to see all rivers across the globe at least once every 21 days. This is a true revolution to understand not only water levels in the rivers, but also in the wetlands. So this is bringing a lot of new information. The satellite was launched last year, and now it's being released the first data. We've been able to assess some of this data over the Amazon. It's indeed very interesting. But again, moving beyond river discharge and river water levels, then it comes to inundation dynamics, inundation extent. Today, we have a lot of data sets that estimate inundation for remote sensing. And we've done this paper recently. It was a nice intercomparison project where we brought many, many data sets, up to 30 inundation data sets, to compare them. And the main goal here was to understand what's the actual inundation extent across the Amazon. How much does it cover the lowlands of the system, of the basin? And this was important because each center, each research group has their own data sets, but we didn't understand the variation among them, the uncertainties on these estimates. So the idea was to combine as many data sets as we could and understand what is the differences among them. So for instance, we got this nice map where the more blue areas show more agreement among data sets. And this can promote, can guide future development of such data sets. And as a conclusion, we had this estimate of the long-term maximum inundation across the basin of 600,000 square kilometers on average every year. But again, this pattern is changing. So this was the paper for which I was nominated today. And what we thought was, okay, we have that many data sets covering the whole basin, and what about the trends? Because that was clear for everybody. That's water levels were changing across Amazonia. So we knew very well, for instance, from the Manaus water level gauge, which is the longest time series that we have in the basin, that the annual maximum water levels were increasing. But how does it translate into inundation extent? So this is what we did in this paper. So by combining several data sets and several products, we were able to estimate this 26% increase in maximum inundation extent since the 80s, which is a massive change in this system. This translates into 25,000 square kilometers of more flooding on average every year. 25,000 square kilometers, to give an scale, should be around the size of Belgium, for instance. So it's a massive area that's being flooded. It's the blue areas that you can see there in the map. All these blue areas get more flooded today than flooded in the past. But you can also go beyond inundation extent. I think about other important hydrological variables that really drive these ecosystems at the local scale. For instance, we were able, by using Landsat data, to estimate changes in flood duration. So this map shows the change in days per year that are more flooded today than in the past. And what we found, for instance, is that in more than 20% of these floodable environments, the inundation duration increased by more than 50 days per year. So that's a lot. If you are a jaguar and you can cope with something like 100 days of flooding per year, can you cope with 150? I don't know. This is something that we really need to understand. We're doing some studies on that, for instance, on floodplain forest, which is the same thing. Floodplain forest is strongly driven by flood duration in the Amazon. So there is different forest types according to flood duration. So it's very likely that with a change in flood duration, the vegetation, the habitats in the wetland also have changed. So this is something that we've been addressing with some forest ecologists. We also assessed connectivity. Connectivity is today a main hydrological variable to understand changes in ecosystems. And here we were able also with Landsat data, and especially over open water systems, because Landsat cannot see that much vegetated wetlands. We were able to compare how surface water connectivity changed from the 80s to today. And as expected, if water levels increased, if inundation extent increased, if duration of inundation increased, connectivity also increases. And we saw that, so I won't go into details on this methodology, but here is a summary where, for instance, for the Maracu floodplain, a relatively small floodplain unit in the Amazon, connected areas for a given distance have increased a lot. So this means for an animal like pirarucu, the arapaima, one of the largest freshwater fish on Earth, that really depends on the connection between the river and the floodplain, this connection changed. And how did it change for the animal? So this is something that we are working. Today we have a project with Dr. Leandro Castello, a former Mamirawa researcher, to understand how this change in connectivity is driving changes, not only on the arapaima individual, but also on the fisheries, because arapaima is today the basis of a whole sector of development in Amazonia associated with the pirarucu, the arapaima management. But as I said, unfortunately, it's not only floods that are increasing. In the last decades, indeed, the maximum water levels have increased a lot in Amazonia, but also when the droughts come, they have been each time worse. So last year, 2023, we had the worst drought ever. I'm sure many of you have seen it in the news, a massive event that affected the whole basin. Usually droughts in Amazonia are more concentrated in specific regions. This year, no, it was widespread. And it disrupted the whole social system, everybody that lives there, because river is the main source, the main means of transportation. So in the city I live in, there's no roads to get to that. Tefé, we can only access by boat or by plane. So you can imagine if we interrupt the river during a drought, that's a massive impact. So hundreds of thousands of people were affected, especially riparian communities, remote communities that simply got without water because we are in the largest river on earth, but it lacks water, it lacks potable water for these people during droughts. They had lack of medicines, lack of food. They couldn't come to the main urban areas to sell their goods, to have access to markets. So that was a whole disruption in the system. And not only people were largely affected, but obviously the ecosystems. So in Tefé, where I live, we have Lake Tefé, a very big lake, and there was the epicenter of one of the worst environmental disasters that we had in Brazil last year, which was the dolphin mortality crisis. So it was September to October last year, and as a researcher, I work with water level monitoring at the lake. We were sharing the news with some communities around Tefé about what was going on with the drought. That the water level was going down very, very quickly from early September onward, and simply from one day to another started arriving many news about carcasses of dolphins in Lake Tefé. And that was a shock, especially for my colleagues from the aquatic mammals research group that we have in the institute that started looking for these carcasses, and then more and more and more carcasses every day, with a peak of 70 individuals dead in 28th of September. That was a shock. If you think about dolphins, if you find more than 2 or 3 carcasses in 2 weeks, that's too much. That's a real red flag. When you find 70 in one day, that's a catastrophe. So we created a whole set of activities to understand what was going on. The Brazilian Ministry of Environment set up an emergency response operation. I got in charge of this environmental monitoring program during this crisis. That was a crazy experience for a researcher, but it was very important to work on it at that time. And that was what we found. We looked at all possible causes of that mortality event, which led to more than 200 dolphins in 1 month. And we didn't find anything except extreme water temperature. So my team measured more than 41 degrees Celsius in the whole water column. It was between 50 centimeters to 2 meters deep, all of it at 40 degrees Celsius. So that's too much. That's been really unexpected and unprecedented for the Amazon. I've been talking to many limnologists that have been measuring water temperature in Amazonia for decades, and none have measured it. Although we can measure 40 degrees in the top surface, in the first few centimeters, when it goes down, usually the temperature goes down very quickly. But what we found was the opposite, 40 degrees Celsius in the whole water column. And not only the maximum water temperature was extreme, but also the dive variation. So temperature could vary from 29 degrees Celsius in the morning to 40 degrees Celsius in the afternoon because of this strong heat loss process. So that was a massive event of lake heat wave. And this was appointed so far as the main cause of this aquatic mammal mortality. And as far as we know, this would be the first case of aquatic mammals death by hyperthermia that we have recorded on Earth. That's a very, very strong message that climate change is bringing us, because this phenomena I didn't bring here, but we are assessing with satellite data long-term trends of warming in Amazonian lakes, and this is very clear. Lakes are increasing widespread. Every lake, we assess 25 lakes across central Amazon, all of them getting much warmer at an average rate of 0.6 degrees Celsius per decade. So that's a lot of warming, and we do need to start thinking about tropical lake heat waves, because Traditionally, in textbooks, we understand, we learn that tropical systems do not vary that much in temperature. On average, it's only 30 degrees Celsius. But actually, what we are showing here is that, yes, it can vary a lot, and it can have very dramatic impacts on ecosystems. But it was not only a drought that occurred in 2023. Unfortunately, disasters today come together with many other disasters. So it's time to think synergistically. It's time to think about compound risks, compound environmental hazards. So all these pictures I took in September and October 2023. So you can see here pictures that show intense sedimentation processes that, together with the drought, isolated whole communities or whole cities, like in figure C on the left. There is a 15,000 people city completely isolated because of sedimentation. It was not only the drought, not only reduced water levels, but also sedimentation processes. We had major algae proliferation, which can be ichthyotoxic, can kill fish, together with the drought. High water temperatures, we had erosion. Remember that the river water level decreases 11, 12 meters every year there. This is a major trigger of river erosion. And when people live, for instance, that picture in figure A, there is a whole community that's been destroyed by erosion. So drought comes also with these major erosion processes. We had fires. Deforestation in the Amazon is a true problem today. And this comes with fires and a lot of smoke across everywhere. So it was very complicated to brave. This is another potential cause of the dolphin mortality as well, because underwater, 40 degrees Celsius. When they go out to brave, it was unbearable to feel that air completely contaminated, completely polluted. So this is one important call, that we start to think more synergistically, more holistically about disasters, not only about one flood or one drought, things that are going on together. And I do think that a key way to address these ongoing challenges is transdisciplinarity, to co-create solutions, to co-create science with multiple colleagues from the high-level science to the ground, to the local people that really understand the system, that really feel the impacts. So I've been very pleased to interact with many, to collaborate with many colleagues in the past years from different disciplines, and I'm sure that I learned much more hydrology from non-hydrologists than from hydrologists today in the last years, because the way other people understand waters is completely different than the way I do, that I understand waters. And this brings so many insights, so many ideas on how to push forward hydrological science in my way. That has been a great, great lesson. So for instance, with these colleagues, we've been able to do very nice works, such as the flux tower at Mamirauá. So next month, we'll start building the first flux tower in the Amazon floodplain to measure greenhouse gas emissions. This is a major advance on understanding global warming in the region and also globally. Working with social scientists to understand river erosion and disaster vulnerability, such as that school. That particular school fell down because of river erosion, and those kids stayed 1 year without classes because of that. This is a major impact that comes together with the drought. Floodplain ecology, and more especially, local communities. Since I've moved there, I'm from the south of Brazil. I've been working with Amazonia for quite a while, but then I moved to Tefé, to the heart of the Amazon, and I've been each time more interacting with these people, these fantastic people with amazing knowledge of these ecosystems, of this environment. So I dedicate to them this presentation, and I've been working very closely to them to co-create solutions, to understand what's going on, and to think how we could decrease the impacts of such changes. And I couldn't be here without the support, the important support of my PhD advisors, very open-minded people that let me do all these different collaborations during my PhD, but also they continue being great collaborators. My family, my research group today, many friends, many colleagues that have been collaborating with me in this agenda. And what about the future? I know I didn't bring today very good news. That was not my purpose, but the world doesn't bring good news as well. So this is I'm sure you know the recent trends of sea surface temperatures. We have record-breaking temperatures worldwide. And this is very, very worrying. Actually, meteorologists, global environmental scientists are not being able to explain what's going on. This jump in global temperatures was expected within 5, 10 years, not now. But this simply changed from May 23 onward. So this is a major change on the global system, and we need to understand it. What we are seeing, increased floods, but also droughts, is very, very well aligned with the projected inundation changes for the Amazon, such as this projection on the bottom. But when I think about the future, actually, I prefer to be more optimistic and let you with this nice picture of the new Amazonian research people that will come in the next decades. They are really optimistic in action. They are really aware of what's going on, and they really want to act. When you think about the dolphin crisis, which I was very, very largely involved with in last year as well, it was a massive disaster. 200 dolphins is around 15% of the lake's population. But that was only one lake in Amazonia. We have thousands of lakes. And we don't know of any mortality event alike in any of these other lakes. So actually, Amazonia is very resilient as well. So after all of these thoughts, I do think we can be optimistic and be more synergistic in our way with the research, and let's do it together. Thank you.
Thank you so much.
Thank you, Dave.
Yes.
Yeah.
Yes. Thank you. Thank you very much for that address. Very challenging news. We might not get too much more optimistic this morning. So we all need to carry on our work in the face of these problems. So it's my pleasure to introduce our plenary speaker that will talk about a wicked problem as well. Dr. Seetha Coleman-Kammula is the president and co-founder of PFAS Solutions, an independent not-for-profit organization committed to doing good science for a healthy environment. Before I move through her very interesting bio, just a sort of full disclaimer. I think having Seetha talk today really embraces the theme of our conference, connecting for freshwater science. Seetha is not a freshwater ecologist, and I'm very fortunate to have met Seetha, and we now have some collaborations going. Seetha is on the Stroudwater Research Board, and I'm on the board of her nonprofit as well. And she comes from a very different background, but very talented. And so I'd just like to share with you a little bit of her history. She's a serial entrepreneur and a former senior vice president of Basel, a Royal Dutch Shell and BASF joint venture. Dr. Coleman-Kammula started as a research scientist in Amsterdam and held diverse positions in 4 countries, managing research and development, strategy, and business units. After retiring from Shell, she served on Dow Chemical Company's Sustainability External Advisory Board and founded Simply Sustain LLC, a management consulting company in sustainability and thinking about cradle-to-cradle plastics. And she currently leads the Center for PFAS Solutions, which specializes in trace-level analyses of PFAS, per and polyfluoroalkyl substances, a group of chemicals of concern. I'm certain that the majority of you are aware. Through research and development of innovative test methods, they offer their clients and collaborators products and solutions to problems resulting from production, formulation, and end use of applications of PFAS. So I'm looking forward to hearing her perspective. Help me welcome Dr. Kammula to the stage.
Very kind. Gee, that was a pretty long introduction, and these lights are right in my eyes, so I'm going to sort of move over here. Good morning. I would like to start with saying my greetings and thanks to a beautiful being called the mayfly. Look how beautiful it is. Give it up, guys, not for me. PFAS, you're not going to hear anything very much more beautiful than that. So, a wicked problem. PFAS, a wicked problem. Wicked problem is a word that I didn't come up with. It's actually one that's used in policy and planning. And there are many forms, many definitions. There's whole protocols. But the one that really struck me is this one. It's a problem with no optimal solutions. Impacts, sources, and scale of the problem all remain uncertain. And solutions often prove elusive. My motivation in using those words is not to leave you hopeless. Yesterday at lunch, somebody said, oh my God, what do I do? It's really the opposite, is to mobilize you to reduce some of those uncertainties, which I'm going to illustrate what these are, and also help develop sustainable solutions. And the word wicked, it really denotes resistance to resolution rather than evil. So why and what are some of the dimensions and the scales and sources of this wicked problem? I tried to summarize a vast area which I could possibly not cover today, but these I thought would illustrate to you. There's not just one PFAS. They've been around a long time, 70 years, 5,000 unique chemical structures. Sometimes the number keeps going up. Every time I see it keeps going up. Went into a lot of different applications, uses. And I was very struck by this number that was actually come up with by the OECD. 2,500 to 5,000 tons of the whole family of PFASs of certain length, C4 to C14. I'll explain what that means. And that's significant. It struck me because soon you will see that the measures we're using are nanograms, not kilograms, not tons, nanograms per liter of water. And the US EPA, after all these years, finally started to reduce the levels they found to be not harmful from 400 to 70 to today it's 4 parts per trillion. That's a pretty large uncertainty they were trying to reduce. And we now find them in all our waters. Something like 45% of US tap water is deemed to have levels above those levels which the EPA says are harmful. And what we now have is what I believe to be a very elusive solution, and that is lawsuits. Again, this number keeps going up, 12,300, 2,035 lawsuits, and every day there are more lawsuits. That cannot be a sustainable solution. That is a symptomatic fix to a fundamental problem we all need to understand. So I hope to be able to illustrate what they are. How did we get here? As I said, they've been around a long time. They didn't start out as PFASs. They started out as fluoropolymers that were actually resulted from an innovation at Penn State using elemental fluorine. Fluorine was used to fluorinate a polymer. They were fluoropolymers. Those were deemed to be useful for extracting uranium, and they were used during the Manhattan Project. And then slowly from there, started to develop products called PTFE, per tetrafluoroethylene, and then we started to get into some sort of everyday products, into pots and pans, which you probably have at home, and but really more into industrial products, fabric coating, textile coating. If you're wearing jackets, you probably have them on there, but waterproof. And then the most important step into this area came from the use of PFASs in the 60s for firefighting foams. They were extremely good at putting out fires, and I'll explain also why they are so good. And in 1970s is when the PFAS uses into multiple products just expanded into vast numbers. I had to look up when the EPA was created. That was in December 1970. So between 1970 and 2000, you had an enormous expansion of these products and these chemistries and the technologies. The result, around 2000, the global distribution grew, and then people said, oh my God, these two chemicals that are called PFOA and PFAS are harmful and voluntarily discontinued. The manufacturers said, we won't make them anymore. But then they started to develop new PFASs, which we're now discovering. And there's a lot of uncertainties about those. High public awareness, and we now have a situation of multiple regulations and escalating lawsuits. So really the message is something that started out as being an essential use product, chemistry that was very useful but troublesome as we started to expand them into our everyday lives. 5,000 chemicals. I don't expect you to read them. I don't think you can. But I just wanted to say that they are divided into classes, subclasses, and subgroups because some people think that they should be regulated as these subclasses. But the two that were really useful were the PFOA and PFAS, PFOS. So those are the two compounds that I'll be referring to as I go through the data. Just remember PFOA and PFAS, and they are carbon. They have 8 carbons each, loaded with fluorine. Every one of those carbons has fluorine atoms, and they have different head groups, carboxylic acids, sulfonic acids. That's the extent of chemistry I'll go into today. But they were also then followed by shorter chain PFASs and longer chain PFASs. And I'll be talking about some of the longer chain PFASs and why they're a concern for your community. And then came things called telomeres, and I'll probably be touching on that. Again, I can't go into all the chemistry. Why were they so useful? They were useful because they were excellent surfactants. Surfactants are used in so many products because they make wetting surfaces, emulsifiers, dispersants, many more. But it wasn't just any old surfactant. Because of the fluorines, it could withstand some extremely high temperatures. But also, it was also had some extremely strong bonds. The carbon-fluorine bond is one of the strongest we know, and therefore one of the most difficult ones to break down. So the more fluorines you had, the higher the temperature it took, and it found its way into many, many essential products, as well as what I call convenience products or consumer products. There's a whole lot of them. We probably have PFAS on the carpet right here, and you're probably sitting on furniture that's got Stainmaster, Scotch Guard repellent. You probably have jackets. Some of us may be wearing, I may be wearing some PFAS-containing cosmetics on my face. I wish I knew that I was, but I didn't. There we go. So here are some of these convenience products, and then some of these useful products. They are essential for our way of life today. Some of the PFASs go into computers, into semiconductors. We have come to depend on them extremely, but not all are essential, and that's the point I'd like to come to later on. The one that actually is of concern is its use in firefighting foam. It was highly effective at putting out hydrocarbon fires. So you have a lot of them, you could have a lot of them, and you do have a lot of them on manufacturing plants, but also when an airplane went down in Dover, well, it was put out. These things are made into firefighting foams. They're called AFFF. They worked extremely well. They smother the fire. They don't allow the oxygen to come in. They put out the fire instantaneously. That got to be problematic because then they were starting to use them for training firefighters, and then the DoD started to say, oh, well, this is great, use it. So on and on the story. My intention is not to say who did what, but the product then got out. PFAS in firefighting foams got out. So the PFAS cycle, it just cycles. And why does it cycle? Because PFASs are extremely soluble. PFOA is very soluble in water. We looked it up yesterday, about 9.5 grams per liter of water, extremely soluble. So wherever they were used, they were produced, the beginning of life. At the beginning, they were produced in factories, and then we wear them. We put then the products, for example, carpets go into landfills. Landfills have water coming through them, and they leach. It's called landfill leachate. Landfill leachate goes often to a wastewater treatment plant. The wastewater treatment plant, as you can follow the cycle there, it can release it into the river. There should be standards, don't you think? Released into the river, wastewater treatment plant, or the firefighting foam, or the sludge that is at the bottom of the wastewater treatment plant, which is labeled biosolids. It's quite good if it is actually screened for these bad chemicals, but you can't. It gets into the biosolids, and I'll share with you some of the data. The biosolids then get used, as they should, because they are full of organic nutrients, but they're also containing PFAS. Now the PFAS is in the farming soil, and through the farming soil, through the food, and through the ground, on and on it goes. It circulates through our planet, except there is no planet B. It is just only one planet, and they keep circling around. So what? Why is it of concern? This has been the debate for the longest time between industry and EPA and the regulators and everybody who's concerned, is how bad are they? So that has been a problem because there were a lot of associations with a whole lot of very many diffuse health issues. I tried to follow. I'm not a toxicologist. It's one thing I really can't understand very much of. But as I started to read more and more of these, I really am convinced that one of the biggest concerns we have is immune suppression in children particularly, of immune response to vaccines. And Grandchamp and Harvard has done studies on children eating fish on Faroe Islands, England don't. I believe is one of the strongest data that's out there is the immune suppression is deemed to be a health impact of highest concern. And then associated with that, with children, of course, is the breast milk. Yesterday, I was having lunch with my Vietnamese mentees, and they showed me some data of breast milk, PFAS in breast milk in Vietnam associated with the production, 393 parts per million, and I said, oh my God. So breast milk, vulnerable population, in the fetus, you can see it, there are certain impacts, and you can read the dashed lines are less impactful or less concerning, and then the solid lines are more concerning. So the jury is now finally out. Sorry, I shouldn't have used that word. They have come to the conclusion that we should not have more than 4 parts per trillion, focus on the maximum contaminant level, that is today, the maximum contaminated level for PFOA, PFOS of 4 parts per trillion, and for the others 10, and then there is a health index I don't have time to explain. The units are what I'd like you to focus on. They're parts per trillion, nanograms per liter. Parts per trillion conceptually is 1 drop in 500 barrels of water. Yesterday, my husband and I were at dinner trying to calculate what is that in terms of the amount of water we drink per day and how much the US consumes, and we just stopped calculating. So 4 parts per trillion is extremely low. But their goal, we are told, should be 0. Well, you can't detect 0, but for now, the challenge is to implement and make sure that all of the water, public water utilities can actually achieve that goal. Don't want to scare you. What is the biggest path of exposure? Drinking water. From that, you can tell it's drinking water. It's the most important exposure route. The amount of consumed, followed by food, and then, of course, occupational exposure, those who actually work in those factories, those who use PFAS, firefighters, ski waxers, and I mean, there's just very specific hotspots of people who are using them who have been tested and have high levels of PFAS in their blood. And as I explained also, babies and fetuses, because they consume more water per body. So what should you do? Here is where it gets tricky. If you're concerned, first of all, write to your water supplier and say, are you testing my water for PFAS, and are you actually publishing that every quarter, as you should, in consumer confidence reports? If it's not and you have a private well, then the best thing you can do is put in a reverse osmosis filter under your sink. You don't need to flush toilets with 4 ppt water, but you do want to have it under your sink or brushing your teeth, wherever it is. But that too is only a symptomatic fix. You get clean water, but reverse osmosis actually, what it does is it removes the PFAS into what's called a concentrate, and then your plumber will probably make sure that that goes into your drainage, and from the drainage it goes into wastewater or into your wastewater treatment plant. It's not a permanent solution, but it is something in the interim that you can do to safeguard yourselves. So how much is there? How prevalent is there? I just want to show. There was just recently a global study by Mallikarjun, I won't mention his name, talked with him. He's done it for all over. And the reason I wanted to show again is to say it's not highly prevalent everywhere. It is prevalent in 4 hotspots. In the Great Lakes Basin, it's detected, it's pretty high, 0.18 to 461 nanograms per gram of dry weight. That must be in the sediment samples. And it's been determined that that came about from fabric protection sprays, furniture, and textiles. And I should also add, Michigan being a major company, a major state with automotive production, there's probably a lot of chrome plating, which is another application where PFAS are used. And then that's one area. One source is really sprays, furniture, and textiles, industrial production. And then you have in Ontario another hotspot, and that is from agricultural use, and that comes from, as I explained, use of biosolids, and they go back in. And Las Vegas wash, I had to look up what it was, but apparently it's one where the wastewater from the city of Las Vegas goes into. So that's pretty bad. So you have a wastewater treatment plant, and biosolids are a second source, and a third source, as I showed already, is fourth one is AFFF. So let me repeat: industrial production, wastewater treatment plants, or should be landfills should be in there, and AFFF, or firefighting foam, where firefighting foam was used. Those are the hot spots, and that's where it's really also a case for environmental justice. Elsie Sunderland at Harvard has done an extensive analysis of PFAS in these hotspots, and she's determined that increases the risk of exposure of PFAS who live around those areas. And they're not really the most well-off people who live around these spots. They are, in fact, one of the more socioeconomically disadvantaged people. So there is a social justice issue around where these hotspots are. So people have tried to call these things PBTs. There is actually an extra letter there. There's PB&T, persistent, bioaccumulative, mobile, and toxins. And I already talked about the toxins work. I'd like to show you some data from our own work in our Center for PFAS Solutions that illustrates just a very limited studies. These are not extensive studies. If there are experts here who know much more than I'm about to share, please forgive me for that, but we did find data from our work that illustrated to us, and we said, oh my God, this is real. And that is persistency, bioaccumulation, and mobility. I'd like to show you some of our own data from our labs. So our lab, which is that little Brandywine shab, you know, that little fish there, that's beautiful. It's actually a fish that's in the Brandywine River. Apparently now there's no longer that many of them. That's our laboratory. It's inside a, little did we know at the time we moved in, a Superfund site. And within the Superfund site, it's actually a much larger area than that map, there is a Delaware Air National Guard in the Newcastle Airport, and there are 11 drinking water wells that were used, and that are still used, to supply the folks who live in Newcastle, historic Newcastle, Delaware. It's actually beautiful. It's got a beautiful town center. It includes, according to the Delaware DENREC, which is our state agency, 5,000 people, 215,000 homes could be beyond just the 5,000 who are supplied. It had 4 parties who used that site: Delaware Air National Guard, Newcastle County Airport, Duncan Readiness Center, and the Army Aviation Support Facility. So there was some training going on, and there were other activities. So there was definitely PFAS-containing AFFF were used on the site. And so we have a plenty of supply of water. We can collect the data. I said, that's one good thing. We're right in the middle. I actually got contacted by somebody from, it was actually, I think she was in Qatar. She wanted to know how to do certain tests, and I said, well, just go out and get some water from, you know, local water supply. And she said, no, but we only have desalination water, reverse osmosis from the sea. So they don't have any contaminated PFAS water around them to test, but we do. Okay, so this is data from a very recent analysis. We are going to show you just data from 4 wells. I apologize for all the names at the bottom. Those are all have definitely what we call a AFFF signature. The one that you should focus on is PFOS, PFOS, and PFOA. Do I have a pointer here somewhere? That one? Oh, right, look at that. How do I do this? Forget it. So PFOS and PFOA. The total can be as much as 6,000 parts per trillion. In well 4, there was 6,000 parts per trillion total, and PFOS alone was, I think, what does it say, about 3,600. Doesn't matter. Beyond 4, it's just what, right? I mean, it's poisonous. This is raw water, untreated water, and well 4 was shut down because they just couldn't even get it out of there to start treating, and so they shut it down, and so they're operating. This is a small community water system. Shut down one of them, and they have 3. They have, in 2014, this water system, along with another one that had the 7 others, artesian water, installed activated carbon filters to remove the PFAS, and 2014. So I tried to go back and say, okay, let me see now. 2000 is when they all agreed they won't produce any more PFOA and PFOS, but of course there was some product in inventory, so it probably got continuous use. And then in 2009 or 10, they started to say, oh my God, we need to do something about the water, and the filters were placed in 14. And in 2019, CDC, ATSDR, it collected the blood samples, blood and urine from 214 residents in Newcastle, in my little, around the area. And we go to the town halls and listen to these people every now and then when the EPA comes down and says, how are you guys doing? Levels of some of the PFAS in blood were as much as 9 or 10 times higher than the national levels. Talk about hotspots. These folks were drinking water. It's actually very good water. It has no nitrates. It doesn't have total organic carbon is pretty low. It was pure water. Till then, they didn't know it was there. And at least 1 PFAS was detected in all participants, and all 7 PFASs were detected in more than 60% of the samples. So 2014, they've been getting clean water. Well, the level, I think the MCL, there was no MCL, the health advisory was 70 parts per trillion. But anyway, you know, it was better than what they were drinking before. And when you look at that, you go, the exposure was reduced, the PFAS remained in their blood. And if you go into the CDC website, you will see these sort of graphs repeated on those areas that are specifically impacted by use of AFFF firefighting foam. This, to me, is really persistent product. It's a very persistent chemicals. And if you then go and look up, you know, scientific data on why are they so persistent, what do we know about their half-lives? Half-life is really where the time it takes for plasma concentrations to decrease by 50%. And there's a variability, as you can imagine. It really, you know, depends on how many people you investigated and how healthy they were, et cetera, et cetera. But this was really from a review of 13 articles, and you can look up Rosato's paper. It's pretty strong evidence. It can be anywhere from 1.5 to 5 years of PFOA. PFOS is longer. Most surprisingly, HXS, which is a shorter chain sulfonic acid, has only got 6 instead of 8 carbons, lives longer, 2.84 to 8.5 years. So persistency is really at the heart of all the PFASs. That's one thing they all have in common. They differ in their physical properties and how they're used and what they're used for, et cetera, but with so many fluorines on the carbon, almost all of them are likely to be persistent and are increasingly shown to be persistent. And those are difficult studies to do. So talk about causes remain uncertain. They remain uncertain because it's very complex to do. Long-chain PFAS in creeks may be indicative of ongoing bioaccumulation. So that's basically what my conclusion is, but I'm going to show you the data. We have a couple of creeks and rivers very close to where we are. There's a red clay, white clay, Brandywine, and a white clay, Site 2. So we sampled surface water with a group of students from the University of Delaware, Jerry Hoffman's group, and you know, we gave them all the precautions on how to sample. Sampling PFAS is how you have to be very careful because you can inadvertently contaminate with your own clothes. We did sampling twice, we did analysis twice because we didn't really believe what we were seeing. The ones in the red and the green are the white clay and Brandywine. They're relatively low. They are around about 10 parts per trillion of those particular PFASs that you see. Well, the level of PFOS, you know, is okay. It's below the MCL of 4 parts per trillion in those 2, which we think are relatively clean. But the PFOA level is higher. So this is surface water that is actually being used by a water company to supply. And it had been supplying it till now. But now that the MCL has come, they're using about $42 million putting in a treatment plant because they use the surface water. They have to treat it and get rid of it. But the most concerning one is the red clay. What you see there in the red clay is a very interesting pattern for us chemists who like to see patterns. We're seeing a short chain PFAS is PFBA, that's a 4-carbon, PPA is 5 and 6, hepta. We're seeing buta, penta, hexa, hepta, octa, and nona. I said, that is a weird pattern, you know. It's like somebody's starting with a higher chain and they're getting chopped down. What might be happening? And we went and looked up if there was a factory, and there is a factory, right at the point where the water was being taken. It was under investigation by the state of Delaware, and then later on we find they actually had a settlement agreement, basically told the factories, you guys investigate and clean up. A year later, we took the samples, they're still there. Okay, so why are they concerning? They are what, some of them are longer chain acids. So the longer chain acids, I've tried to show you, is anything beyond 8. PFNA is a nona, it's a 9 carbon. PFDA is 10 carbon. Deca, undeca is 11. And then you have dodeca and trideca, PFDOA, PFTRDA. They're there above the MCL. And they're concerned because they are longer chains. They're of concern due to the higher bioaccumulation factors, which can impact health of aquatic species. Next, I'll show you what the bioaccumulation study, this is a study done by an EPA scientist, and maybe a bit difficult to follow, but basically what you're seeing on the left is PFHXS, that is the 6-carbon sulfonic acid, and PFOS is 8-carbon sulfonic acid per fluoro. And you see on the log scale how different, how much higher the bioaccumulation factor is when you just increase the carbon chain by 2 carbons. And you see the same with the carboxylic acids. PFOA is 8 carbons, PFDA is 10 carbons. You're also seeing a higher bioaccumulation factor for longer chains. And that was in the whole body versus muscle. You see some differences. So that all depends. There's a whole complicated science as to how PFAS get into your body and where they reside in our bodies. But I found this one, Elsie Sunderland. She's done some really great work. This is a large amount of data from New Hampshire. And what you see on that scale is the log bioaccumulation factor. As you go from the carboxylic acids, that is the PFOA is one of those, from 3 carbons up to 12 carbons, the bioaccumulation factor goes up, and the sulfonic acids likewise. And the more concerning things are these beasts that are now called precursors. Basically, precursors are precursors to a more permanent set of PFASs. They break down and give more permanent terminal PFASs, and they are present in those fish. I think the work now is going to head. I'm going to touch a little bit on where the gaps are for those of you who may be looking for areas to study. Precursors and sediments, we just don't know what they are even, because standards don't even exist, samples don't even exist. We only know when they break down, or we have to bring these products, the sediments, into our lab and do an artificial degradation through a method called top analysis. We break them down, and then we go, oh, it broke down and gave us these fragments, so it must be that. We're spending taxpayer money to find things which the industry knows. Precursors are wicked, the wickedest of them all, in my opinion. We just don't know what they are. Talk about uncertainties unfolding. This is the work we did with Stroud Water Research. Deanna, if she's here. To me, it was astounding that we actually did this work, because it was done on probably one of the only studies that were done on farms. Can you imagine any farmer giving anybody permission to come and study PFAS in their soil? Yeah, lady, come and study and put me out of business. But we did. That's really speaks to the kind of trust that Stroud has built with farmers through the work that they do with farmers. So this was quite a large study, and our objective was to see if biosolids are used on soils, what happens, where do they go, do you find them, do you actually find evidence that they are actually going into the soil? And we did, and what we found is different PFAS species migrate into soil to different depths. I've got still 20 minutes, that's good. So this is the level in the biosolids itself. One of the farmers actually had biosolids that were waiting to be spread on the soil, and you see a certain pattern. I want to draw your attention to the scale that is now no longer in parts per trillion, it's parts per billion, right? This is a very heavily contaminated biosolid. parts per billion. So not nanograms per gram, but micrograms per gram. And milligrams per gram would be ppm, but I don't think we ever saw any ppm. So the PFOS level is 30 parts per billion, and PFOA was around about 15. And then there were these things that are called 5,3-FTCA, which are actually telomeres, which I will talk about. So what happened? So that's just look at the trends. And we took samples, soil cores, 0 to 15, and they're starting to go down. This is the same soil. The biosolids were not, sort of immediately, they were applied shortly before we did the soil samples. And you go even deeper, and they go down even more. But the most interesting thing to me is what happened to those red bars on either side of those green bars, the PFBA, PA, XAA. Where did they go? Why aren't we seeing them in the soil? And why aren't we seeing the longer ones in the soil? And where we're seeing them, the shorter ones, we're seeing them in the runoff, in the water. So the short chains are more soluble in water, and that's known. They're actually in the runoff in the water. The most concerning of this is, of course, the PFOA, which does have a health advisory. We don't know what, there may be other things going on in other farms and so on, so we really can't conclude much in this. But to the extent that this is a field study, this is a pretty good evidence that biosolids do contaminate farming soil, and that there are different phenomena and different ways of migration of these into the soil and water on farms. Backed up by perhaps one of the more controlled studies, I think it is a more controlled study, by Gwyn Johnson at Portland, Oregon State, I think. She actually had much more useful facility. It's an ag school. They had, land at the back. They could actually study controlled and continuous use, and she found exactly the same things. So really, our findings are backed, even though we couldn't do as strict a study as we could have done. We did do some controls, but we really didn't know how old the biosolids were that are applied, for how long they were applied, and whether they were from the same source or not. You can't even know if the biosolids came from the same source, because a wastewater treatment plant will call an aggregator and say, hey, come and take it away, and then he'll go to the next wastewater treatment plant and then he'll mix it up. So it's very hard to do what we did at Stroud, but Gwen actually managed to do it because she could apply and she could do exactly the same conclusions that what we saw. The last one is really on a wastewater treatment plant. This one is one where we studied, it was an EPA-funded study to investigate PFAS in the wastewater infrastructure in Delaware. The reason that we reasoned that we need to do that because there's been a lot of consolidation of smaller wastewater treatment plants in small towns bringing into larger wastewater treatment, and we didn't know what that was going. And we did, I think we did three different county-level wastewater treatment plants, and what you see is PFAS in the influent is in blue, and the effluent is in red, so it is taking some of them out. But the one that caught our attention is the one we're calling wastewater plant B, and both were taken in the same period in December. And what we saw in the influent was this product that was, again, in micrograms per liter, so that's parts per billion, 180. We said, why is there so much more of that FTCA in plant B? Where could it be coming from? These are small rural wastewater plants. We then learned that the wastewater plant B processes landfill leachate. If those of you who don't know what landfill leachate is, landfills, some of them are lined, some of them are not lined. And anyway, if they're lined, then there is a leachate. that comes out, especially because, they're open. I mean, there's rain comes in, and the leachate then often goes to a wastewater treatment plant. And the one in Wilmington, where we are, there is the DSWA, Delaware Solid Waste Authority, landfill is here, the wastewater treatment that the city of Wilmington runs is there. They just ship that across, and then it gets used and treated. But it doesn't really get treated because wastewater treatment plants don't have a way of removing PFAS. So what we found is the leachate itself, we got sample of that, which actually is, these are all hard things to do because nobody wants to give you samples because they're scared. So we found 15,000. The leachate, landfill leachate, is one of the heaviest concentrated bits of PFAS. If we know that, we ought to do something about it because it is now going into a wastewater treatment plant which can't deal with it, and then it gets released into where? Freshwater, eventually into the marine environment. So this is pretty depressing. Why does leachate have so much? You should be asking yourself. It's because of all the stuff that we throw away that goes in, including, of course, other stuff like activated carbon that we use to filter PFAS out of. Anything highly concentrated we can't do anything with, we put in landfills. It doesn't go away. It just comes right back into the cycle. So our observations and implications from the wastewater treatment study probably are one of the strongest, and I'm going to move into recommendations. There are some changes in the effluent of the wastewater treatment plants, which we studied. They were above the drinking water levels of MCLs, right? Wastewater, even the one that were not so bad, the levels were above the MCLs. So if regulators are going to say, look, wastewater treatment plant, before you release it, you make sure it's the same level as drinking water. It's not happening today. It should. It really should. And there's need to protect freshwater sources. So only in 2021, 3 years ago, the EPA announced plans for new wastewater regulations. They're still not out. But they did say drinking water should be 4, but they're not doing anything about what comes upstream, which is wastewater. The product which we think is really pretty astounding is 250 parts per trillion of the plant B of this FTCA, which is concerning because it does actually break down into a final terminal product, which is not good at all. And it is one of the largest chemicals that Marty Barlatz in North Carolina did a national study, and it showed that it's present in large amounts. So we ought to stop producing that. It's a paper coating, textile coating product. Landfills are really the final stages in the life cycle. Landfill leachate is of concern due to the PFAS things that are called precursors, which I won't have time to go into. So very briefly about the treatment solutions. Current practices, people say what's being done. As I said, it's really to make them, absorb them, use products that are called activated carbon and exchange resins. And these are giant towers, they're columns, but they become saturated. They don't last forever because these are, just go and stick on the surface. And then at some point, the PFAS break through, the absorbent material, and this treatment, then the treatment plant needs to replace the media. And what is happening now, and we got a little bit of money again from the EPA, is the vendors of these treatment products are coming and saying, oh yeah, carbon worked over there, so it'll work here. It's a plug and play. Ion exchange worked there, it'll work here. And data is showing it is not. Every water is different, as you well know. It'll have nitrate, sulfate, chlorides, and dissolved carbon, and they all interfere with the interaction of PFAS with the media. So we're doing some work now trying to train them and trying to develop a protocol and decision trees for these small water systems in Delaware to say, You need to really do something that is suitable for you and what works on your site. Oh yeah, sorry, let me just go back. I think I touched on that before. What happens to the spent carbon? And on exchange resin, the EPA is now starting a study on what to be done about them because they remain on there and then they go from there to the landfill and then you haven't done anything any good for anybody. Lastly, the destruction. The race is on for taking PFAS from all the contaminated sites and destroy them. But I am very skeptical, so are a lot of people, about these technologies. Many of them claim, yeah, I put PFOA in a test tube and I zapped it with plasma and electrolysis or photolysis, sonolysis, and I can just thermally degrade. Well, what we don't know is in real water, where there is more than just the PFOA, PFOS that's in the lab, there are lots of other things, and in much higher concentrations, and also things that we don't know. And what we don't know is when you do any of these technologies, what they are degrading to. The same of these, some of these you might have seen the incineration story of plastics and solid waste. When you incinerate, you just don't know what they are becoming. And if they are completely destroyed, if this PFAS is destroyed completely to fluorine, which is the element that the whole cycle started, mass balance of I think I had so much fluorine in the water that I put into these treatment systems, and then in the end, I got so much fluorine or fluoride. That's not there. And so to me, this is still a very developing and an elusive solution. So concluding, I really come back to this definition. I just want you to remember that about the wicked problem. The scale, source, and impacts are uncertain, unfolding, and solutions are elusive, but you all can help. And I think I'm going to share with you my own personal feelings and thoughts about what we all can do about the wicked problem. PFAS measurement and monitoring is very resource intensive. I haven't even told you about the difficulties we have in our lab chasing PFAS contamination. Measuring something to 4 ppt is extremely difficult, very difficult. Standards don't exist. We buy pipette tips. Pipette tips, contamination for pipette tips, it turns out, to get the drop to drop really carefully, they put PFAS in the tips. And the amount of time we spend chasing, those levels of contamination is just unbelievable. And we only know a small percentage of the thousands of chemicals. It's shifting the burden to public water utilities. Basically, they're the guys who are now told, you've got to filter it to 4 parts per trillion. They're new and they're complex. PFAS from wastewater effluent threaten. Oh no, I need to leave 15 minutes for questions. Wastewater effluent threatens freshwater ecosystems. Complete remediation is elusive. What we can really do is we need to lobby for global regulatory system for these persistent chemicals. Persistence alone is enough. Production, use, and emissions are global. There's an urgent need to set PFAS standards for discharges from wastewater, and they really must limit current production. And products containing PFAS must be labeled as PFAS containing, so all of us who are buying can say, I don't want to buy this stuff, and that's the way to curb the demand and production of these wicked chemicals going into these products which we don't need. I ran over time. Or no, I actually got to 10, but sorry. Just give me one slide, and that is for thanking these folks who made all that data possible. 2 of them I really have to call out, Shauhan and Jess, who are on the either end of the front. They are my Shambhala warriors, I call them. If any of you know Zen Buddhism, the Shambhala warriors go around, slaying demons of ego. So they go around slaying PFASs through our whole lab.
Thank you, Seetha. We do have time for a few questions. So raise your hand and Sherry and I can come around and give you the mic if you, anyone? Way in the back there, why don't you come forward too?
I can't see who that is, but
If you could offer one piece of advice to people who live in these Superfund sites, what would it be?
could you repeat that? If I had one piece of advice?
For people who live in these Superfund sites, similar to the one you guys studied, what would that be?
Can you repeat that, Dave?
Yeah, if you had one piece of advice for people who live in similar Superfund sites to the one you studied, what would that be?
If I had advice for people who live around Superfund sites, is that the question?
Yes.
Sorry, I think I'm losing a little bit of my hearing too. Good reason to go get hearing aids. You should do two things. One is to, the EPA has ultimate responsibilities for these Superfund sites. They have community reps. You need to rattle the cages to tell them, what are you doing? And if that Superfund has PFAS, then I would tell all the people living around, if they have their own private wells, to put reverse osmosis filters in there under the sink. And yeah, and then, you know, your water is clean, but then you can't do much about the reject that goes into the sewer system. That's really what I would be, EPA.
Sherry, right here.
Hello. My question is, have you ever found, like during your field studies, any system that can naturally absorb PFAS or like store PFAS? Or like especially in your study in the farmland, have you got any site where the PFAS was being mineralized naturally? Or are there any natural ways to get it fixed in micro ecosystems?
The last part of your question was, are there any natural ways to fix PFAS?
Yeah.
Well, the race is on for that as well, and it's incomplete. It's very, very hard. There are, you know, the traditional way of treating, for example, MTBE, methyl tertiary butyl ether, in gas stations that are contaminated or chlorinated. Those microbes don't work for PFAS. And so contaminated site remediation involves digging up the soil and doing what's called soil washing, and even worse, in Alaska, there are two companies that do thermal treatment of soil. They're actually literally putting in electrodes under the soil in cold temperatures outside Alaska Air Force Base, heating the heck out, and then just really either, you know, incinerating or destroying PFAS underground. Does that answer your question?
And then with the heat, were they able to destroy that?
I'm sorry?
With the heat, did they destroy it? Like, were they successful?
Well, yeah, that's a very good question. Does the heat destroy it? It depends on how you define destroy. If the standard is, yeah, you make the PFOA and PFOS go down, it goes down, but it then goes down and becomes what? Right? So that's not known. And I think there's now an increasing concern of the thermal degradation results to perhaps just fluorinated hydrocarbons, which are even worse in terms they are, you know, ozone depleting and greenhouse gas. Yeah.
Time for one more question. Gary?
I'll be around, so, and I also won't have these lights in my face, so please come and see me. Sure.
Sure, thank you for that presentation, Seetha. So the only real solution to PFAS is turning off the spigot of PFAS production, just like PFAS and PFOA, but those are voluntarily phased out. So what do you see as a prospect for actually sort of turning off the production of these compounds? What we have in the environment, of course, are highly persistent, but what do you see as the future of reducing the source?
Yeah, so there is a big movement both in the US and Sweden particularly, and I was telling, and the European Union is seriously considering, you know, the classifying PFAS into three categories: essential use, and I forget, I think it was actually on my slide somewhere, essential use, ones that you can find PFAS replacements, non-fluorine containing replacements for PFAS and uses. And the last ones were not at all needed, right? And I heard the other day that Ursula von der Leyen actually created a lot of commotion by saying they're going to give certain PFAS as exemptions for essential products like semiconductors and batteries because they come in now and impact your global warming and your alternative green energy things. So I think that's where it's going to go. The other pressure would be on brands. I've seen that happen in the plastics and sustainability in phthalates and bisphenol A. Basically, brand reputation for brands, that's everything. When they see their name, on the front of the New York Times, when Nike saw its name on the front saying it was using children to make their soccer balls, that stopped. This is why I think it is so important for us to know if the products we're buying have PFAS, because we can take a stand. And there's one thing brands don't like is their names on the front pages. Their brand value goes down. Their share price drops. So the second is for us to use our leverage for demand. We can wait for regulators to do what they can, but in the US it's extremely much more difficult because of the legal. They've got to use all of these safe drinking water, clean, all these things, which CERCLA and RCRA and all of those things. So it's very hard. I think it really has to come down to saying we'll stop production of these non-essential, find replacements, but hopefully there will be replacements that don't cost your next cycle of PFAS, right? Fluorine-free could be, but who knows what will create another wicked problem in a few years. But philosophically, I really think it's up to us to define essentiality in our lives. Very hard to do. I can't live without computers. I can't live without running water, but there are maybe other things that I say, I don't need to buy, I don't need. So part of it is our ways of life to decide which of these artificially produced products, did we really need stain-resistant carpets? I don't know, it's nice. Did I answer that question for you? I really got to leave and let you go get your coffee.